what truly lies behind the long-term durability and exceptional performance of an edge band? How are innovative new materials developed? How is perfect adhesion guaranteed under varying machine conditions? And how can we ensure that every single roll produced delivers consistent high quality? We have directed all these questions to our R&D manager. Welcome, R2. So, let's start right from the very beginning. In your opinion, where is the foundation for a good edge band truly laid?
The answer is actually clear. It's about raw materials. Everyone is interested in final product, but few people know the importance of raw material quality. An edge banding is only as good as materials that enters the extruder. The core of the matter actually begins there. We too begin with each and every polymer that we supply by examining its degree of polymerization and its molecular weight distribution. Furthermore, for the various additive materials that we utilize, we implement stringent specifications covering such critical parameters as MFI, viscosity, thermal stability, consistent color, and UV resistance. Because a single low-quality raw material can introduce an instability into the polymer chain, and this can go completely unnoticed, affecting the entire production batch. The color tone might shift slightly. Rheological properties and viscosity, and even the polymer's overall fluidity, can also change. Even if they don't appear in the final product, these can disrupt the mass flow in the extrusion line, causing you trouble in the machine. The source of all of them is actually the raw material.
Well, when we consider the manufacturing aspect, the most talked about subject in recent times has been zero-line technologies. What has been your approach concerning this?
That's right. The market is moving towards glueless systems. Specifically, hot air technology has now become a standard for many manufacturers. We made sure to take this into careful consideration while developing our Zero Line Pro functional layer. We worked not only in the lab, but also in the field. We conducted tests on different machine brands at varying line speeds and temperatures, and optimized the activation energy and cohesive strength of layer that we used underneath.
Machine-based differences are also crucial, I mean.
That's absolutely right. The critical point here is that the customer should not be forced to constantly fine-tune their machine. We've kept the thermoplastic activation temperature range as wide as possible so the product can work stably even under varying production conditions. We must deliver the same consistent performance across all of them. This flexibility is the most important factor, ensuring its reliability in real production environments.
At this point, I'd like to ask you this. What are the most common issues clients approach you with, and what kind of requests do you receive most often?
It never changes. Color harmony and tonal differences are truly always our top priority. But we don't just call this color. This is actually a matter of surface morphology. A customer picks up a manufacturer's chipboard or MDF, and they want the edge band to perfectly integrate with that surface. There's a pattern involved, a brightness level, and the depth of the surface. We even know that the pattern's orientation is important. All of these elements must be in perfect harmony. As the R&D department, we are constantly dealing with details every week. Sometimes, a customer will bring us a sample for analysis. Look, this chipboard or MDF needs tape, he says. So we take it to the laboratory. We examine it thoroughly under light. We then determine which specific patterns and cylinders need to be used. We pass it through a color spectrometer to meticulously evaluate its delta E values, metamerism behavior, L, A, B measurements, surface gloss, and emboss alignment. Because it's not suitable for the customer, it needs to be a seamless whole.
One of the most sources of confusion is the selection of the appropriate bonding technique. Is it EVA, PUR, laser, or perhaps hot air? If you were in their shoes, what kind of roadmap would you draw for someone making a new investment?
No single right way. It varies depending on the specific type of chipboard or MDF we are using. It can vary depending on the edge banding material, production volume, and the level of quality that is expected. It's a system dependent on the application. EVA hot melt systems are the most commonly used adhesive systems worldwide. They are compatible with cost-effective ABS and PVC edge bands, work on every machine, and are adequate for general production. Besides these advantages, there are also downsides. Heat and moisture resistance is limited. In heat over 60 degrees or high humidity, the glue line can soften and create a risk of opening. This means EVA hot melt is risky in areas like kitchens and bathrooms. And that's where the polyurethane system, what we call PUR system, comes into play. PUR system is on a completely different level. It creates a chemical bond, not mechanical. Because it bonds chemically, it acts much stronger. It is resistant to water, steam, and heat. That's why it's an indispensable product for areas such as kitchens and bathrooms. However, alongside these advantages, it naturally comes with some disadvantages. This system demands a longer machine warm-up period, and you must perform more meticulous cleaning in the adhesive tank to prevent any ash buildup. So, while the polyurethane hot melt system delivers high performance, it still requires strict process discipline.
Well, there are numerous adhesion methods out there, and glueless systems are certainly attracting a lot of attention. If we were to make a comparison between these, what exactly are your thoughts on this particular subject?
Actually, this is a very comprehensive topic. We need to explain all the methods in detail, comparing their advantages and disadvantages. I think it would be more appropriate to make this topic into a separate video.
Alright then, the topic for our next discussion is now clear. In our very next video, we will be discussing different adhesion methods. Mr. Ertu, thank you very much.
Thank you very much.